Hello, good morning everyone. So today we are discuss about preparation methods of alkyl halides. Okay, so first alkyl halides preparation methods of alkyl halides. Alkyl halides. Okay, so there are 7 methods in preparation of alkyl halides. So first preparation method from alkanes. Second one from alkenes. Next third one from alkynes. So next fourth one from alkyl halides. Then fifth one from alcohols. Okay, from alcohols. Next sixth one. Okay, sixth one from carbonyl compounds. Okay, next to seventh one from carboxylic acids. So there are 7 methods in preparation of alkyl halides or haloalkanes. So first one from alkanes, from alkenes. Next third one from alkynes, from alkyl halides, from alcohols, from carbonyl compounds, from carboxylic acids. Okay, there are 7 methods. So we are discuss about preparation of alkyl halides from alkanes. So first one from alkanes, Okay, from alkanes. So this method also called as photohalogenation. It is also called as photohalogenation. Okay, photohalogenation. So in this reaction, alkanes are substrates. So for example, I can take methane. So this is a alkane. Okay, so alkane halogenation in presence of sunlight. Okay, in presence of sunlight. Here one hydrogen replaced, okay, by the halogen atom. So we get alkyl halides. Okay, we get alkyl halides. So here we can take methane. So that's why we get a methane halide. Okay, methane halide. So for example, CH4 can take X2 in sunlight. So here one hydrogen atom replaced by the halogen atom. So we get CH3X. So I can use one more halogen in presence of sunlight. So here one more hydrogen atom, okay, one more hydrogen atom replaced by the halogen atom, we get CH2X2. So I can use one more halogen atom in presence of sunlight. So here also one hydrogen replaced by another halogen atom, we get CHX3. So this is the halo form. So I can use 1 mole of X2 plus sunlight, okay, sunlight. So here remaining hydrogen replaced by the hydrogen atom. So we get, so here these hydrogen replaced by the halogen atom, we get CH, we get CX3, okay. So carbon tetra halide, okay. This is the halogenation. So why it is called photohalogenation? So halogenation takes place in presence of sunlight, so that's why we call as photohalogenation, okay, photohalogenation. So photohalogenation takes place, sunlight also, or heat, presence of heat also takes place, photohalogenation. So in photohalogenation follows free radical mechanism. Photohalogenation follows free radical mechanism. So what is the free radical? Free radical means odd electron species are called free radicals, okay. Odd electron species are called free radicals. So free radicals formed as intermediate in photohalogenation reaction. So photohalogenation reactions, so then the first one, photohalogenation, first fluorination, then second one chlorination, next third one bromination, next fourth one iodination, okay, iodination. So in these 4 halogenation topics, so chlorination is most important topic, okay. Then first discuss about the fluorination, okay, fluorination. So first topic, fluorination, okay, fluorination. So here fluorine is a small size because of it is highly reactive element. So whenever the hydrocarbons are alkane, so this is a methane alkane, so react with the fluorine. So fluorine is a highly reactive due to the more electronegative element and small size. It is vigorously react with hydrocarbons to produce carbon black, and hydrogen fluoride, okay. It is a exothermic reaction. So it is exothermic, it is highly exothermic reactions. So highly exothermic, it is highly exothermic reactions. So because of more amount of energy is released in that reactions. So exothermic reaction enthalpy sign indicates negative, okay, negative sign. So enthalpy is negative sign, that indicates the amount of energy is released in that reaction. So that's why it is a exothermic reactions. So only one line given in NCERT, okay. So next to second one, which is chlorination. Okay, this is an important topic, chlorination. Second one, chlorination. Okay, so chlorination. So first I can take a hydrocarbon, okay, this is the methane. So react with chlorine in presence of sunlight or heat, okay, sunlight or heat. So here one hydrogen atom in methane replaced by the chlorine, so we get a methyl chloride and HCl. This is the reaction. So in chlorination process, this process takes place in 3 steps. Okay, 3 steps. First one is step 1. Step 1, chain initiation step. Chain initiation step. Okay, chain initiation step. Okay, chain initiation step. So generally this reaction takes place in presence of sunlight. So in presence of sunlight, homolytic fission takes place. So what is the homolytic fission? So I can take Cl bond Cl. So homolytic fission takes place in presence of sunlight. So that means the bond pair electrons equally shared between the 2 atoms. So here Cl electronegativity difference is 0. So that's why one electron displacement towards this chlorine, another electron displacement towards this chlorine. Okay, so only one electron displacement towards this chlorine. Just a minute. Only one electron, half a carbon. So we get free radicals, 2Cl radical, 2Cl radical, okay, 2Cl radical. This is the chain initiation step. So I can take second step, step 2. Step 2 is chain propagation step. Chain propagation. So what is the chain propagation? So here in chain propagation steps, reaction takes place infinity times. Okay, infinity times. So I can write here hydrocarbon methane and chlorine. Okay, so in methane, hydrogen atom replaced by the chlorine free radicals, so we get methyl chloride. Okay, methyl chloride and so just a minute. Okay, so here one hydrogen bind with the chlorine, so we get HCl. Okay, HCl and a methyl radical. Okay, methyl radical. So again this methyl radical. Methyl radical react with Cl2 molecules to produce methyl chloride and Cl radical. Okay, Cl radical. Again this Cl radical react with the methane to produce methyl radical. Again this methyl radical react with chlorine to produce chlorine radical. That means this reaction takes place infinity times. Okay, infinity times. So that means this reaction never end in this step. So this is a chain propagation step. So I can write chain. Okay, step 3rd. Okay, step 3rd. So this is the chain termination step. Okay, chain termination step. Okay, chain termination. So what happened in chain termination step? So there is no free radicals produced as product. Okay, there is no. So So I can write here chain termination step, CH3 radical plus Cl radical gives rise to CH3 Cl, and Cl radical plus Cl radical gives rise to Cl2, and CH3 radical plus CH3 radical combines to give ethane. So here there is no free radicals formed as a product. So that's why this is a chain termination step. Okay, chain termination step. Then okay. So next, for example, so I can write here ethane molecule. Okay, ethane molecule. Here monochlorination takes place in these reactions. Okay, so my question is, how many possible products are formed? Okay, how many possible products in that reactions? Okay, in that reaction. So I can write the second question, propane. So this is a propane, and monohalogenation in presence of sunlight. So how many isomers are possible? Okay, how many isomers are possible? Here, how many isomers are possible? So two questions. So here monochlorination means only one chlorine replaced by the halogen atom. Sorry, only one hydrogen replaced by the halogen atom. Okay, only one hydrogen replaced by the halogen atom. So here this is the ethane. So how many types of hydrogens is there? Only one kind of hydrogen is there. This is the primary hydrogens. These three hydrogen also primary hydrogens. So in monochlorination, ethane gives only one product. So that is the ethyl chloride. Okay, ethyl chloride, CH3 CH2Cl. Okay, that is the ethyl chloride. So this is a 1-chloroethane. So here in second question. So how many how many isomers are possible in this reaction? So here two types of hydrogens is there. So first one, this is the primary hydrogen. So here also primary hydrogen. What are the primary hydrogen? The hydrogen atoms which are directly attached to primary carbon. So that type of hydrogens are called primary hydrogens. So what is the secondary hydrogen? The hydrogen atoms which are directly attached to secondary carbon, hydrogens are called secondary hydrogen. So these two hydrogens connected to secondary carbon, that's why these are the secondary hydrogens. Okay, secondary hydrogen. So here two types of hydrogens is there, 6 primary hydrogens and 2 secondary hydrogens. So any primary hydrogen replaced by the chlorine, we get one type of products. We get one type of product, that is a 1-chloropropene. So 1-chloropropene, product 1, CH3, CH2 and CH2Cl. 1-chloropropene. Okay, 1-chloropropane. So whenever the secondary hydrogen atoms, okay, secondary hydrogen of these two hydrogen atom replaced by the chlorine, so we get another product. So we get another product. Another product is 2-chloropropane. Okay, 2-chloropropane. So here my question is, so which is the major product, which is the minor product? So which is the major product and which is the minor product? So I can give some values of primary, secondary, tertiary hydrogens. So here, so note, I can give some values of primary, secondary, tertiary hydrogen. So here, this is a first degree hydrogen, value is 1. Okay, value is 1. So I can write second degree hydrogen, so value is 3.8. Okay, So I can write the third degree hydrogen, so value 5. Okay, these are the values of primary hydrogen, secondary hydrogen and tertiary hydrogen. So in first case, okay, and first product, so here how many number of primary hydrogens is there? 6 hydrogens. Okay, these are 3 primary hydrogens, these are the 3 primary hydrogens, so total 6 hydrogens. Okay, 6. So now value, so primary hydrogen value is 1, 6 into 1, so equals to 6. So I can write secondary hydrogens. Secondary hydrogen, these are the secondary hydrogens. So how many secondary hydrogen? 2 secondary hydrogens. So value is 3.8 equals to 7.6. Which is the higher value? So this is a higher value. That's why this is a major product. Okay, major product. Major product. So now first one is that this is the lesser value, this is the minor product. So minor product. So minor product. Okay, minor product. So then, so which is the, so examiner asking this percentage, how much percentage of 1-chloropropane, how much percentage of 2-chloropropane. Okay, so how to calculate the percentage? Okay, how to calculate the percentage? So percentage of this is a 1-chloropropane. So 1-chloropropane. So I can calculate the percent. Okay, percent. So this contribute is 6. This contribution is a 6. So total contribution 6 plus 7.6. 13.6 into percentage 100. So how much value? So we get a 44.11 percentage. Okay, this is the 11 percentage. Okay, second one. So this is the first one. So I can 2-chloropropane. Second one calculated 2-chloropropane. 2-chloropropane. So calculate the percentage. Okay, percentage. So how much contribution of the 2-chloropropane? 7.6. Okay, so total contribution 6 plus 7.6, 13.6 into 100. So how much percentage of product produced? So 55.88 percentage. So which is a major product? Second one is a major product. Okay, so next I can write one more example. Okay, one more example. So third one. So one more example. Okay, one more example. Okay, so this is a 2-methyl butane on monochlorination. Okay, on monochlorination in presence of sunlight. So how many isomers are possible? How many isomers are possible? So here this is the primary hydrogen, this is the secondary hydrogens, this is the tertiary hydrogen, this is also primary hydrogens, primary hydrogen. So here how many number of primary hydrogens are there? Okay, 9 primary hydrogens is there. So here this hydrogen, okay, this hydrogen atom replaced by chlorine atom. So which product is obtained? So which product is obtained? So first product, this hydrogen replaced by this chlorine atom, so we get one product. So Cl, CH2 and CH, CH3 and CH2 and CH3. Okay, CH3. So whenever this hydrogen, okay, this hydrogen replaced by the chlorine atom, which product is obtained? Has same product. So has same products. So now I can write here CH3, CH, CH2, Cl. This hydrogen replaced by the chlorine atom. So we get CH2 and CH3. So what is, both compounds are same. So because of same IUPAC name. So this is a 1, 2, 3, 4. Okay. So 1 chloro 2 methyl butane. So here also this is a prefix. So 1, 2, 3, 4. So 2 methyl, 1 chloro 2 methyl butane. So both are same product. This hydrogen and this hydrogen give same products. Okay. So that's why it gives only one product. So this is a one product. Okay. So okay, one. So this is the one product. Okay. So next I can write this hydrogen replaced by, okay, this hydrogen replaced by the chlorine atom, we get another product. We get another product. Okay, we get another product CH3, Cl and CH3. So this compound name is, okay, so 2 chloro 2 methyl butane. Okay, 2 chloro 2 methyl butane. So I can write this hydrogen replaced by, okay, this hydrogen replaced by chlorine atom, we get another product CH3, CH, then CH3, CH2, okay, CH2, just a minute. Okay, CH, Cl and CH3. So this is a 2 chloro 3 methyl butane, another product. So I can write this hydrogen replaced by the halogen atom. So we get another product CH3, H, Cl. So this is a 1 chloro 3 methyl butane. So 4 products are obtained. So how many isomers are possible? 4 isomers are possible. So including stereoisomers, examiner asking including stereoisomers, how many structural isomers are possible? How many isomers are possible? So here, so I can take, so do you know the chiral carbon? Do you know the chiral carbon? So what is the chiral carbon? So chiral carbon means the carbon which contains 4 different groups. The carbon which contains 4 different groups. This carbon contains 4 different groups, that is the chiral carbon. So here the first compounds, as a chiral carbon is there. So chiral carbon is there. So this carbon has 2 hydrogens. So there is no chirality. This carbon has 1 hydrogen, 1 chloromethyl group, 1 methyl group, 1 ethyl group. So that's why this is the chiral center. Okay, chiral center. Okay, chiral center. Okay, chiral center. Okay. Next, second compound. So this is not chiral because of 3 hydrogens. This is not chiral because of 3 hydrogens. So here this carbon has 2 methyl groups. So that's why this is not chiral. So 2 hydrogen. This is not chiral. This is not chiral. Okay. So next, I can write the third compound. So here. This is there is no, so this carbon contains 3 hydrogens, no chirality. So this carbon contains 2 methyl groups, no chirality. This carbon contains 3 hydrogen, no chirality. This is the chiral carbon. Okay, this is the chiral carbon because of it has 1 hydrogen, 1 methyl group, 1 chlorine, 1 isopropyl. So that's why this is the chiral center. So here any chiral center is there, there is no chiral center because of this carbon has 2 methyl groups same. So there is no chiral center. So only examiner asking only isomers, only structural isomers are possible. Structural isomers are 4 structural isomers. In examiner asking including the stereoisomers, how many number of isomers including the stereoisomers? So stereoisomers, chiral carbon containing compound shows the stereochemistry. So covered, it considered as the 2. So it is considered as a 2. So this is the remaining are 1. So 2, 3, 3 plus 2, 5, 5 plus 1, 6. Including the stereoisomers, the possible isomers are 6. Okay. Only the structural isomers are 4. Okay. Structural isomers are 4. Okay. 1, 2, 3, 4 structural isomers. Including the stereoisomers, we consider as the chiral centers. So I can take one more example. Okay. One more example. Okay, so one more example. So my question is monochlorination. Sorry, just a minute. Okay, monochlorination in presence of sunlight. So how many isomers are possible including stereoisomers? How many isomers are possible including stereoisomers? So here in case here this hydrogen replaced by the chlorine atom, so we get one product Cl. So in case here also one hydrogen is there. Okay, one hydrogen is there. This hydrogen replaced by the chlorine atom, so we get another product Cl. Okay, so here this hydrogen and these two hydrogen, this is the secondary hydrogens. So this is the secondary hydrogens. These two hydrogens are same. Okay, so whenever these 4 hydrogen atoms, any hydrogen atom replaced by the chlorine, we get one product. So that is this one. Okay, so next, so this is also secondary hydrogens. So 4 secondary hydrogens not same. So because of this is the first position, second position, next to third. Just a minute. Okay, so here this is a 1, 2, 3, 4. Okay, so secondary hydrogens, this is the secondary hydrogens. These 4 hydrogens are same. So because of these 4 are present in second position, so next to secondary hydrogens and the secondary hydrogen. These 4 hydrogens are different from this second position hydrogens because of this position is third. Okay, so next this is also secondary hydrogen. This is the 4th position hydrates. So whenever the 3rd position hydrogens are replaced by the chlorine atom, so we get a new product. So this is the one product. Okay, next, so whenever the 4th position hydrogen replaced by the chlorine atom, so we get this is the product. Okay, this is a product. So which is so how many isomers are possible? Well, how many structural isomers are possible? So 1, 2, 3, 4, 5 structural isomers, including the stereoisomers. Okay, including the stereoisomers. So I can consider the chiral carbon. So here any chiral carbon is there. So there is no chiral carbon. So here any chiral carbon is there. There is no chiral carbon. So here this is the chiral carbon. Okay, this is a chiral carbon because of different environment. So this is also chiral carbon. So chiral carbon considers the 2 isomers. This is the 2 isomers. Any chiral carbon is there, there is no chiral carbon. So here also there is no chiral carbon, here also there is no chiral carbons. Only structural isomers, okay, structural isomers, okay, structural isomers are 1, 2, 3, 4, 5. Okay, structural isomers are 5. So next to including the stereoisomers, so addition the 2, so 7 isomers. So here this 1, 2 plus 2, 4, 4 plus 2, 6, 6 plus 1, 7. Okay, so next I can take one more example. Here monochlorination, okay, here dichlorination. So I can take cyclopentane, okay, cyclopentane. On monochlorination, so chlorination in presence of sunlight. So how many products are possible? Okay, how many products are possible? Okay, how many products are possible? So first product, here 2 hydrogens is there, the 2 hydrogen replaced by the 2 chlorine atom. So dichlorination, condition is dichlorination. So previously we have discussed about monochlorination, here dichlorination. Dichlorination means 2 hydrogen atoms replaced by 2 chlorine atoms. So we get, so first product Cl, so 2 hydrogen atoms replaced by the halogen atoms by same position. So next to third possibility, so 1 and 2. So next to second possibility, next to 1 and third position. So next 1 and 4th position, there is no 4th position. So this is a 1, 2, 3, 4, 5. So here this is the 1, 1. So next to 2, 3. Okay. So next here 1, 2, 3. So 1, 2, 3. Well, same position. Okay. 1, 2, 3. So only 3 isomers are possible. Okay. Only 3 structural isomers are possible in that compounds. So I can write one more example. Okay, one more example. Same. Okay. Chlorination in presence of sunlight, dichlorination or dihalogenation. Okay. So here, so how many products are possible? So here both hydrogens are replaced by here chlorine. So this is a one possibility. So I can write, so this is another possibility. Okay. So next Cl, this is another possibility. Okay. So next Cl, this is another possibility. So here if hydrogen replaced by this hydrogen, we get a third product same. If hydrogen replaced by this carbon, we get a second product same. So next to possibility. Okay. So here chlorine. So this is a one possibility. Okay. Next another possibility. Another possibility. Okay. So next so here one possibility. Okay, so next this is the another possibility. Okay, next this is the one possibility. Okay, so next one more possibility. Okay, so these are the structural isomers of this compound. Okay, so next topic, second preparation method. Okay, second preparation method from alkenes. Okay, from alkenes. From alkenes. Okay, from alkenes. So here through two methods are there. First one, addition of HX. Addition of HX. So second one, addition of X2. Okay, so this reaction also called as hydrohalogenation. Okay, hydrohalogenation. 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 Okay, this reaction also called as addition of HX, also called as halogenation. Halogenation. Okay, so next here substrate is alkene. Substrate means starting materials are called substrate. Okay, so here alkane. So first addition of HX. So I can take first reaction, addition of HX. Addition of HX. Okay. So next I can take alkene CH2 double bond CH2. Okay, so alkenes undergoes to which type of reactions? Electrophilic addition reactions. Electrophilic addition reactions. So that means this reaction initiated by the electrophile. This reaction initiated by the electrophile. So here addition of HX, H bond X. Okay, so X is the more electronegative element. That's why this is a partial negative charge, this is the partial positive charge. Okay, so alkenes are electron rich species because of double bond is there. So double bond is loosely bond, weak bond. Double bond is the weak bond when compared to the sigma bond. So here this is the nucleophile, this is a electrophile. H plus is the electrophile. In this reaction initiated by the electrophile. This electrophile attack on here, so we get CH2 and this carbon converts to CH3. This is a plus charge. So remaining part negative X minus attack on here. So we get X, CH2 and CH3. Okay, this is a alkyl halide. So preparation of alkyl halide, addition of HX. This is a addition reactions. Okay, addition reactions. So addition reaction means two compounds combine to give single product, that is the addition reactions. So this is a alkene one product, HX one product. These two products combines to give single products, that's why this is the addition reaction. So what is the electrophilic addition? This reaction initiated by the electrophile. Electrophile means H plus. Electrophile, electron deficient species are called electrophiles. Okay, electrophiles. So this is the one example. So next, so here no problem. So I can write second example, unsymmetrical alkene. Okay, unsymmetrical alkene, CH double bond CH2. Okay, double bond CH2. This is a symmetrical alkene, no problem. This electron displacement towards H plus ion, we get carbocation. So this is the unsymmetrical alkene because of double bonded, both side different atoms. So here 2 carbon and left side, right side 1 carbon atom. So here both are same. This is a symmetrical alkene, this is a unsymmetrical alkene. So here, okay, here 2 possibilities is there. So 1 electron displacement towards here, this is the A possibility. So another electron displacement towards here, this is the B possibility. Okay, B possibility. So A possibility we get CH3, CH2, CH2. So here electron displacement towards this carbon. So this is the A possibility, electron displacement towards this carbon gets negative, this carbon gets positive. Okay, this carbon gets positive. So I can write B possibility. Okay, B possibility, electron displacement towards here. So we get a CH3, CH, electron displacement towards this carbon gets negative, and this carbon gets positive. So we know that stability of carbocation and stability of carbanion. So which carbocation is more stable? Here plus charge present on secondary carbon, here positive charge present on primary carbon. So primary carbon and secondary carbon, which is the most stable? Secondary carbon is most stable. Okay, next with respect to anion, so this is the carbanion, this is the carbanion. So this is the primary carbanion, this is the secondary carbanion. Which is the most stable? Primary carbanion is more stable when compared to the secondary carbanion. So that's why this is not feasible. Okay, this is not feasible. That means a less stable compound. Okay, less stable. Okay, this is a more stable. So more stable. Okay, so that's why electrophile. Okay, electrophile. So addition of HX, H and X minus H plus. So where the H plus attack, so this is the most stable and this is the feasible. So that's why H plus ion attack on here. So we get a CH3 and CH3 plus. This is the secondary carbocation. Secondary carbocation is more stable than X minus. X minus is the nucleophile. This X minus attack on here. So we get CH3 Cl and CH3 2-chloropropane. This is a major product. So 1-chloropropane is not major product. So 2-chloropropane is major product. So here we know that some rule, Markovnikov rule and anti-Markovnikov rule. Okay, Markovnikov rule and anti-Markovnikov rule. First I can discuss about the Markovnikov rule. MK rule. So that means Markovnikov rule. Okay, MK rule. Markovnikov rule. So Markovnikov rule means, according to Markovnikov rule, the negative part of the reagent, okay, negative part of the reagent added to double bonded carbon atoms, double bonded carbon atom which has lower number of hydrogens. So here HX is the reagent. Okay, HX is reagent. Okay, HX is reagent. So here I can take HX. So instead of Cl I can write X. Just a minute. Okay, X. Okay, so here HX is there. Okay, so this is the reagent. Here which is the negative part? So H minus is the negative part. So which is the positive part? H plus is the positive part. According to MK rule, Markovnikov rule, the negative part of the reagent added to double bonded carbon atom, okay, added to double bonded carbon atom which has lower number of hydrogens. So here 2 hydrogens, here 1 hydrogen. Halogen attached to here, H plus attached to here. So that's why we get these products. Okay. So this is the Markovnikov rule. So what is the anti-Markovnikov rule? AMK rule, anti-Markovnikov rule. Anti-Markovnikov rule means, according to anti-Markovnikov rule, the negative part of the reagent, okay, negative part of the reagent added to double bonded carbon atom which has higher number of hydrogens. So this topic discussed about some time. So next I can one more example. I can take some more examples. So for example, alkene, okay, alkene HBr H2O2. So it follows anti-Markovnikov rule, AMKR, anti-Markovnikov rule. Next to alkene, so alkene must be unsymmetrical, HCl, okay, HCl H2O2, hydrogen peroxide. It follows Markovnikov rule. Only HBr and H2O2 follows anti-Markovnikov rule. So here MK rule. So next to alkene and H2O2. So it is also follows Markovnikov rule. Okay, Markovnikov rule. So now I'm discussing about the Markovnikov and anti-Markovnikov. So anti-Markovnikov rule also called Karash effect. Okay, Karash effect. Okay, anti-Markovnikov rule also called as Karash effect. Okay, Karash effect. Okay, Karash effect. So what is the anti-Markovnikov rule? So I can take unsymmetrical alkene, so unsymmetrical alkene. So here negative part of the reagent. So suppose I can take HX. This is the reagent negative part, this is the negative part. Okay, so this is the positive part. Okay, according to anti-Markovnikov rule, okay, according to anti-Markovnikov rule, the negative part of the reagent added to double bonded carbon atoms which has higher number of hydrogens. Here only one hydrogen, here two hydrogens. So that's why X minus attack on here. That is the anti-Markovnikov rule. So what is the Markovnikov rule? So Markovnikov rule means, according to Markovnikov rule, negative part of the reagent. So negative part of the reagent is X minus, which attacks on double bonded carbon atom which has less number of hydrogens. Okay, which has less number of hydrogens. So this is the Markovnikov rule and anti-Markovnikov rule. So compound should follows anti-Markovnikov rule. Reagent is hydrogen, bromide and H2O2. So remaining all cases follows Markovnikov rule. Only in this case follows anti-Markovnikov rule. Only in this case follows Markovnikov rule. So next I can take some more examples. Some more examples. HCl, okay, HCl, what will happen? Okay, so next to second one, which product is obtained. So both are unsymmetrical alkene. So in this reaction, so addition of alkenes, carbocation formed as an intermediate. So any reaction carbocation formed as an intermediate, in that reaction, okay, in that reaction carbocation rearrangement takes place, and a less stable carbocation rearranges to more stable carbocation. Okay, less stable carbocation rearranges to more stable carbocation. So I can write first one, So here electron displacement towards here this H minus Cl, H plus and Cl minus. So the alkanes undergoes to electrophilic addition reaction. That means this reaction initiated by electrophile. So that's why in first step H plus ion is involved. This H plus ion attack on here. So we get CH plus and CH3. This is the secondary carbocation. So any carbocation rearrangement is possible. So whenever this hydrogen shifted to here, we get primary carbocation. So primary carbocation is less stable when compared to the secondary carbocation. So that's why there is no possibility. So then Cl minus attack on here. So we get CH3, Cl and CH3. So 2-chloropropane. So but in that reaction, so here H plus ion is there and Cl minus. Alkene, this reaction initiated by the electrophile. So electron displacement towards here, this H plus ion attack here. So we get CH3 and CH3, CH and this carbon. Electron displacement towards this carbon gets positive charge and CH. This is the secondary carbocation. Okay, this is the secondary carbocation. Okay, secondary carbocation. So in this carbocation rearrangement takes place. Okay, so in electrophilic addition reactions carbocation formed as the intermediate. So that's why in that reaction rearrangement takes place. Less stable carbocation rearranges to more stable carbocation. So that means this hydrogen atom displacement towards here, hydride ion, H minus ion, hydride ion, H minus shift. So possibility. So we get tertiary carbocation. So whenever the H minus leave this carbon gets positive. This is the carbocation, tertiary carbocation, and a less stable carbocation rearranges to more stable carbocation. This is the less stable because of less hyperconjugation. Only alpha hydrogens are 3 plus 1 4. Here alpha hydrogen 3 plus 2 7. 8 alpha hydrogen. That's why this is a more stable carbocation. So then H plus are involved like to Cl minus. Cl minus attack on here. So we get CH and CH3, Cl, CH2 and CH3. This is a major product. Okay, this is a major product. So here Markovnikov rule is suitable for this reaction. Not suitable. So because of in that reaction carbocation formed as a intermediate. So that's why rearrangement takes place. So you should follow the Markovnikov rule. So according to Markovnikov rule, the negative part of the reagent Cl minus attack on less number of hydrogens. So here only one hydrogen, here two hydrogen. Cl minus attack here, H minus attack here. So we get this product CH3 and CH3, CH, CH2, Cl and CH3. This is the correct product? No. So in electrophilic addition of alkenes, carbocation rearrangement takes place. Less stable carbocation rearranges to more stable carbocation. Okay. So one more possibility, ring expansion. Okay, ring expansion also possible. So any reactions carbocation is formed as intermediate. So ring expansion also possible. Okay, ring expansion also possible. So for example, so I can take, just a minute. Just wait. So this is the one compound is there. So here HCl, okay, HCl. So here this is the plus, this is the minus, okay. So here double bond is there, alkene. So here electron displacement towards this carbon gets negative, this carbon gets positive. And the secondary carbocation is more stable. So that's why electron displacement towards here, this carbon gets negative. So a negative, positive is attacked. So we get carbocation. Okay, carbocation. So this is the 4-membered ring. Okay, this is a 4-membered ring. So generally 4-membered rings are less stable when compared to the 5-membered and 6-membered ring. So here ring expansion is possible. Okay, ring expansion is possible. So how to ring expansion is possible? So here this is the first carbon, second and third, 4, 5. Okay, 5 carbon. So here bond breaking. Okay, bond breaking. Okay, bond breaking between, okay, between 2-3 carbons. Okay, between 2 and 3 carbons. Okay, 3 carbons. Next, second possibility, bond making between 1 and 3 carbon atoms. 1 and 3 carbon atoms. Okay, 1 and 3 carbon atoms. Okay, so next, positive charge. So positive charge. So positive charge shift from 1 to 2 positions. Okay, 2 position. So it can shift out in the second position shift out. So that means, so first one, bond breaking between 2 and 3rd carbon atom. So here bond breaking takes place. Okay, bond breaking takes place. So 1 and 3 bond making takes place. Okay, bond making takes place. So then positive charge shift from first position to second position. So here first position charge and second position. So here 1, 2, 3. So I can write so this is the 5th carbon, 4th carbon, next 3rd carbon, this is the 2nd carbon. So first carbon 1 methyl group. So 1-3 bond making, 2-3 bond breaking. So charge shift from 1 to second position. So here charge is there. So I can write another way this compound. So 5-membered ring. So this is the first carbon 1 methyl. So first carbon connected to second and third. This is the second, this is the third. So next, third connected to fourth, 4 connected to 5. So 5 connected to 2. So charge shift from first position to second position. This is the charge. So we know that this is the secondary carbocation. Secondary carbocation. So in secondary carbocation is less stable when compared to tertiary carbocation. That's why here hydride ion shift is there. Okay, hydride ion shift. H minus shifted to here. H minus shifted to here. So we get tertiary carbocation. This H minus shifted here, we get tertiary carbocation. Hydride ion shift. Okay, hydride ion shift. Okay, so then here Cl minus is there. Okay, Cl minus. This Cl minus attack on here. So we get this product. Okay, we get this product. Okay, so this is a second preparation methods of alkyl halide. So we get so just a minute. Cl minus attack on here. We get Cl. This is the product. Okay, some more preparations are there. So I can explain the next session. Thank you everyone.